forms of rational numbers. Most of what we're going to do here, whoops, there it is. Most of this we've already done. There's going to be one new thing that we're going to add in here. Can somebody tell me what notebook page we're on?
82.
82, thank you. So the first part of this should be review. The second part will be new, and it might be a little confusing, so I'm going to give you some steps to follow. The first thing is just taking a fraction and turning it into a decimal. The first way we used to do this was long division. And remember that when we did that, that one of the things to help you if you're doing long division, and by the way, we're not going to do a lot of long division, but as a reminder, that one of the things you need to do is to think about 3/8 in this example. Is it a whole fraction? Is it a whole number, excuse me? Is it more than 1 or less than 1? Anybody? Vincent? Less than 1, right? So then your answer should also be less than 1. So if you get the numbers in the wrong spots, the 3 and the 8, and you get a number bigger than 1, then you know you did it wrong. So just a quick review of this form, even though I'm not going to ask you to do a lot of this, I just want to review it. Since 3 is a whole number, we put a decimal after it and we add some zeros because otherwise we can't do the work. 8 into 3, it's not going to go, so we can start with the 0, and I'm going to start with 8 into 30. That would go 3 times, we'd do 24, we'd get a remainder of 6. I bring down a 0. 8 will go into 67 times, get a remainder of 4. And the idea with this was that as long as you have remainders, if you're doing decimals, you have to keep adding zeros until either it ends and you just get a final answer, and this is called a terminating decimal because to terminate means to end, and this decimal has an end. Now, the other choice could be that maybe it starts to repeat. As soon as you see a repeating pattern, you can stop. So for example, if you were doing 2/3 and you did long division, you're going to see the 6 repeats endlessly. You only have to write the repeating value once, or the repeating pattern once, and you only put a bar over the number that repeats. So you will also see repeating decimals. Now, we have been taking shortcuts in how to do this lately, and that's by using your calculator. So I'm not going to ask you to do much long division. You can use your calculator, because I'm going to give you something in a minute that's the new part, and I'm going to ask you to spend more time on that, because I think you guys are good at long division by now, most of you. Just be aware, terminating, repeating decimals. These are all rational numbers, so you will get either a terminating or a repeating decimal. What you're not going to get is a number like pi that is considered irrational because it goes with no pattern to infinity. There's no end to that decimal. It's not rational. Doesn't make sense. How can that be? So we're not going to have any that are like that. Now, before I continue with the new stuff, the other stuff that you might be asked to do that is review is to go the other way, to take a decimal and turn it into a fraction. So the easiest way to do that is to read the decimal using the place value of the final digit. Can someone tell me how would we read this using the actual place value? Diego? 3 hundredths. There we go, done. If you can simplify, you simplify. So we've done a bunch of this in the past. If you had a whole number in front, let's say it was 1.5, 1 and 5/10, 1 and, bless you, 5/10. So if there's a whole number in front of the decimal, it's a whole number in a mixed number. The 5/10 we could simplify to 1.5. So again, if you have a whole number in front of the decimal, that just becomes a whole number. All you have to do is turn the decimal part into the fraction. Using the same method, read it, use the place value of the last digit. That place value is your denominator. Hundredths, hundredths, tenths, tenths. Simple, right? Everybody awake?
Yes.
Okay, here's the new stuff. In fact, for this, I like to use my notes for this as well. Now, here's the different thing that in the past, every time we've come across it, I said, hey guys, we're not gonna do that. We now need to turn a repeating decimal into a fraction. And this is a little trickier. Because if it's a repeating decimal, for example, 0.7 repeated, well, that 7 repeats to infinity. So I can't say this is 7/10, because it's not. It's 7, 7, 7, 7. There's more 7s. So there is a pattern of steps that I'm going to ask you to follow for this. And I will try to explain it as clearly as I can. It is a little confusing. Okay? So step 1, the number that we're given, we use a capital N to represent it. So capital N is the number you start with. And I'm using that because that's how the book explains it. There are other ways to think about it, but this is the clearest way to do it, although it is still a little confusing. Now, we're going to use a little n to represent the amount of repeating digits. How many numbers are there that are repeating? So this one is just 0.7 repeated. So 1 digit repeats, the 7. But we could have, maybe it goes 7, 2, 7, 2, 7, 2, 7, 2 until the end of time. Then this little n would be a 2, the amount of digits that repeat, 7, 2, 7, 2, 2 digits repeat. Here, this little n will be 1 because only 1 digit repeats, the 7. Okay, so in this example, n equals 1. Okay, so I'm just kind of showing you on this example, the n is 1. The n is the amount of repeating digits. Everybody's with me that there's only 1, right? The 7 is the only repeating digit. Okay, step 2. Now what I'm going to do on this is I'm going to be using these variables, the big N and the little n, to show what we do, and then to the right side I'll do the work for this particular problem. Step 2 is we're going to multiply base 10 to our little n, which we just said was 1, times big N. Well, big N is our original number, right? Big N up here, the number you start with. So here's what this problem would look like. So here's what you do every time. Okay, this part on the left. Here's what we're going to do. Here's the stuff for this problem.
Miss Tuttle,
Yes?
can you let Christopher know the sweater's here? Thank you.
Is that you? Okay. 10 to the power of 1. Why 1? Because our little n is a 1. Okay? Times big N. Okay, what's our big N? It's the number we started with. Now, in this case, 10 to the power of 1 is how much? Tammy? Just 10, right? So in this case, it's just 10. If it was 10 to the power of 2, because we had 2 repeating digits, 10 squared would become 100. So I'm just kind of going step by step here. Now, what happens if I multiply by 10? What is going to happen with the decimal here if I multiply by 10? Let me go over to the side here and show you what I mean. What if instead of this decimal, repeating decimal, what if I had 10 times, let's say, 8.5, just a regular decimal? You don't have to write this down. What would happen with this is 1 0 is going to do what to the decimal? Diego? It's going to move, 1 0 means the decimal is going to move 1 place, and this would become 85. So same thing here, 1 0, this decimal is going to move 1 place. So what I get when I do this, the 7 is in front of the decimal, but what's after the decimal in this? If it was a repeating 7, what's coming after, Jaden? 7. That is still repeating, right? Because this would be 7. 7 repeated means 7, 7, 7, right, until the end of time. If I move the decimal 1 place because I multiplied by 10, look what's still there is that repeating 7 is now after the decimal. So really all you're doing is you're moving the decimal however many places there are of a repeat. 1 repeat, we move the decimal 1 place. Step 3, there's only one more step. Step 3 is gonna be, we're gonna take, now this is, I'm gonna write underneath this is the answer to number 2. Step 2. Notice what we did up here in step 2, 10 to the little n times the big N. So I'm gonna take that answer. Again, on the left side, I'm showing the pattern of what we do. And now we're gonna subtract our original number from it. I promise we're almost done. I know it's confusing. This is the hardest thing we'll do this chapter probably. But you guys can do it, I promise. Okay, this says the answer to step 2. The answer to step 2 is right up here. Right, we got our 7.7 repeated. 7.7 repeated minus our original number. Now, here's the tricky part. It's a little hard to explain. We do this, but on the left side, we need to rewrite our variables that we started with. And I'm going to show you why. This will just give us a whole number. Remember what we're doing here is we're turning this decimal into a fraction. If I just subtract this, I get 7. That's not a fraction. So on the left side, I'm going to actually take the steps that I wrote in red, and I'm going to write them down. 10 to the power of 1 times n. 10 to the power of 1 times n. If this was 10 squared, I'd write 100n. But this one is 10 to the power of 1. 10 to the power of 1 is just 10 times n, there it is, and I say minus n. This is like we've combined like terms on the left side and the right side. I'm just going to subtract down. 10n minus 1n leaves how many n's? 9n. 0.7 minus 0.7, well, those repeating 7s are going to disappear because that's the same amount minus itself, that makes 0. 7 minus 0, 7. So the tricky part here is we take this pattern and the pattern gets written on the left and the actual numbers get written on the right. And we set it up with equal signs in between. 10 to the power of n, well, that equals this. I know it from here. It's my answer. Minus my original number, minus my original number. My final step, how do I get n by itself? How do I find out what this is as a fraction if it's being multiplied by 9? I divide by 9. There's my fraction. How do we know if we did it right? How can I turn this fraction into a decimal and see if it starts where we started? Vincent? 7 divided by 9, and there's my repeating 7 that I started with. So your final answer, you should be able to divide it on your calculator and get the repeating decimal that you started with. Let me just talk through it one more time. Step 1, you just label your parts. Okay, here's my big N, here's my little n. So step 1, you're just identifying the big N and the little n. Step 2, you plug in your little n and your big N here, and you multiply it out, which basically means you're moving the decimal however many zeros you have. 1 0, 1 place. Then you take the answer to step 2 and you subtract the original number. You write the pattern of that on the left, you write the actual numbers on the right, and you solve. I know it's hard. That doesn't mean we're not going to do it though. You can do it. I know you can.